to not make mistakes in C, or how to find them if you make them. Right?
Right, thank you.
Yours.
Well, it's not only me, it's Arjen as well. He originally is from the Netherlands, but now lives in Brisbane, and we figured I've got a closer trip to here than he has. So we work together on this. And, well, the Australians like their snakes. By the way, if anyone's interested, that's a brown snake. If you get bitten, it's not neurotoxic, so you better not get bitten. But I heard it's only 1% dying of the bites because they got good medical treatment. So at least good news for that part. Yeah, well, if it's not too remote, and they notice you die, so, well, anyways. Plenty of options, but it's pretty much the same with code. If you got a bug in there, maybe someone finds it, maybe someone exploits it. You never know whether you're going to die of this, or your program is going to die of this. So we're right here. And what basically happened is Arjen played around a bit with sudo and looked at the code. And his reasoning to look at sudo was, well, it is covered by Coverity checks, so it should be checked for any obvious flaws in code or anything that generates trouble. And plus sudo is probably as old as Unix is, and that means it's not really, but really old. It's so old, I've never seen a Unix without it, and maybe I'm a year younger than you. So the good news is we assumed it must actually be old enough to be free of bugs, which we wanted to challenge. And we figured it's a bit too much work to work our way through all of the lines of code that we roughly estimated to be some 700,000. That includes documentation and blah, so we might remove a few, but it is quite efficient or useful not to do this manually. So we figured that's probably not going to be a big issue. Because if you look at the make file that sudo provides, if you want to compile it, there is a Coverity check in there, there's a CPP check in there, there's splint in there, there's spell in there, and there's flaw finder in there, and much more, which should actually help us find any issues. And we could even make C go through with wall and wextra, or wextra, or however you want to call it, so it would find relevant flaws, if that's the proper GCC. If you're using a Mac and you're using the GCC that's on the Mac, that comes with Xcode, minus wextra is different. So it finds less, because it's different C. Just a hint for those using a Mac. Well, so that's the make file, and things should work out really nicely. And they do the Coverity checks. So Coverity would probably, because that's a great online tool, find everything that's wrong. And me saying that is probably getting you to what's going to be there. No, it's not finding everything. And that's the bad news. So we figured run GCC. And if you look at the documentation, there's rather new feature, the extra, which adds a set more of warnings than all does, which we're not really surprised of. That's because it's extra. And we then thought, well, let's integrate it into building sudo. And that's very simple. We just set some C flags and run configure, run make. And what would you guess? Would you expect any issues to arise? Hands up who thinks there were any issues. So there's a few that assume if you give a talk, there must be issues, but you don't know where, right? So some are guessing there's some, and others are guessing there's none. And some are indecisive, probably. Right, are you? Okay. Well, so be surprised. Let's look at this piece of code. Do you find the snake that's sitting in the grass and ready to bite? It's not really venomous, but it's an annoying one. Who of you, hands up, who of you codes C? Just a quick hands up. Who speaks C? Okay, fair enough. That's half of the group. You've got it, yeah. The argv, it's not a counter. So it's a subtle typo that just so happens. I mean, we're humans. We sometimes misspell things, and that happens. I've probably got some typos in the slides as well. So that will happen. That's normal human behavior. And that is something that we should actually find. Well, Coverity didn't find it. Let me tell you so much. And that's a bit weird, because we would expect it to find that this doesn't match. I would.
Yeah.
You too.
No, no. 0 is also 4.
Yeah, but it doesn't. It's proper, but it's not really proper at this point, in that way. So it's weird. So it should at least generate a warning, I reckon. But if you run GCC, it tells you that doesn't really match. And it's not comparing to 0, but it's looking where it's greater than 0. So that is, again, something different. Yeah, it's a warning, and that's good. If you set minus W error, it becomes an error. But the warning is there for a reason. We don't have a warning just because we want a warning, but we have a warning because there's something that might go wrong. And that's the argument we have here, or the point that we want to make. Because, well, it's probably not going to make sudo hackable. We're probably not going to be able to break into a system using this flaw. I'm quite confident to say that. So that's at least good news. They fixed it in the meantime, so it's even better news. It was a quick fix, wasn't it? But what I find odd is Coverity didn't notice, Splint doesn't notice, CPP checker doesn't notice. No one notices. And it even took you quite a time to notice the flaw. Yeah? Pardon? W extra noticed, yeah. Something did, yeah. But what we see here is we can't rely on just one piece. We need a set of tools to actually find things. If we rely on one, if we rely on us, it's probably going to be overseen. And it's very important to really use all the features that we have to find all these little tiny pieces of things that go wrong. The fix, obviously, is simple. I've got the patch file here if anyone wants to apply this to a sudo. And you literally see it's tiny. And we already talked about this. So what we see as a result of this is, why don't we by default use W extra on any compile? It just helps us find things that potentially could be an issue. If we fix them and W extra stops complaining, the world gets a bit better. Well, there's ways of getting around these warnings if you want to, but it would be so easy. It doesn't cost you a penny. Just add a W extra to your makefile by default, and it's done. And you get all the warnings, and you know what's wrong, and you know what could potentially go wrong when testing. And it gives you no excuses, because obviously if it's not on by default, you forgot it. And we humans, we keep forgetting things. At least that's what I've heard about humans. Some of you are rude, they won't forget things, but that's a different issue. So make sure you fix them. They've got a reason. It's the same as getting a flat tire warning in your car. Yes, your car is still running. It's still good. But it's got a reason, and you should fix it, because you might get into trouble after a while. Was that raise 10 or just stretching? Okay. And once you've fixed all of them, just add this W error, which we just discussed earlier, because that will stop you compiling, and you'll get an error message, and you're forced to remove any warnings. That's very good for educational purposes and for cleanliness of code. And it's simple. It's easy. It's straightforward. What we also recommend is preventing some mishaps that could happen. So if we've got parameters that we don't use in a function for whatever reason we have, we could just void that parameter and we're happy. We could get rid of any missing initializers. because it's not going to annoy us. So we get rid of these warnings. It's simple. It is straightforward. Make things explicit that you have implicitly in code. I know everything gets initialized most often to 0, but sometimes it doesn't, and things go wrong. I don't want to remember the OpenSSL Heartbleed issue at this point, which has added complexity by creating their own alloc function, or malloc function. So that generated the issue, which was reasonable from their point of view, but you know, adding complexity makes things worse and increases risks. So, looking at it, that actually here is a very weird function that no one would use in his sane mind, but we pass, for some odd reason, we pass a value to it. It doesn't make any sense, but it's got everything covered. That's the answer to all questions. So we're good. The left one will generate a warning if used with already extra, because it tells you you've got a parameter that you're not using. So now you might have a reason for some weird backwards compatibility. I don't know why. People got reasons for legacy. I don't want to know. I don't even want to think about it. But if you're not using this, add the extra void value and you're happy. No complaints. Which, however, ends up being odd. Because if you then assign a value to the voided thing, it won't complain, which I think it should, because now it's nonsensical. Again, so sometimes you don't get rid of all the potential trouble that you could run into. But that's the issue with potential trouble. Pardon? Yeah. There's lots of fun in there. Coverity is also a nice thing. And I'm not saying Coverity is a bad idea. I think it's a very good idea to run your code through Coverity. And the sudo team does. They also prepared a bunch of further make targets that actually would help making secure, safe, bug-free, clean, nice, beautiful code. I mean, they've even got uncrustify in there, so it looks nice. They've got code spell in there to find typos. They've got splint in there, CPP check, and PVS Studio, which is all nice stuff. I mean, beautiful code, find typos, oops, and all that jazz. So I figured, rather than using uncrustify, I'd first go and try check format, which, uncrustify, sorry, I was mixed up. So we first ran check format, which runs uncrustify, which we would expect to work, wouldn't we? It was in a make file. It's a make target. Except for, we got an error message, unable to load the config file. So they don't have an uncrustify config file. Why do they have a uncrustify make target? I mean, you've got the tool. Someone must have used it back in the days. Now, since they've got Coverity, it seems like they don't take care of at least this one here. Well, okay, fair enough. We would have hope for this, but it doesn't work. But then, we can know that they're not using their uncrustify. So they're not obeying to their own coding standards, quite potentially, which uncrustify would support, which would prevent issues. Anyways, we figured let's go into things that actually find errors or issues, and let's run splint. There's a make target for this. Well, except for it crashes. And it's not like it's one file. I manually went through a few hundred files for removing the parse errors that we got to test whether splint would actually find something. It was a bit of a mess. I didn't really cleanly remove them. I ended up just commenting some stuff out so we could get Splint working for testing purposes. But that's not exactly what I expect if I got a Splint target. A Splint target is useful. It's got a reason why it's there. It's because we are humans. But it seems like, well, Coverity has taken over. So we fixed it. I removed a few lines. We still get 882 warnings from Splint. So even if they were able to run it, it should zero out that line. At least that was our expectation. And that's what we would like to see in code. And just, again, asking, why is there make Splint if it's not used? I know, it wasn't me. It was broken before me. Well, you know the sentence. It wasn't me. Never. It's never me. It's probably because it's got a vintage status, yeah. So it doesn't need to go through anything. No, I think that's a development thing. And it changed over time. So you change your tooling over time and you didn't take care of the old tools, which were there for a reason. And that's often with lines of code, that's often with something that we find in code. And that's dangerous, in my belief. So let's go for a CPP checker. After finding 74 lines with issues, that was in a clean version again, it wasn't a Splint modified one. It aborts with an error 6, which means we can't use it anymore. And it finds some simple stuff here. Unsigned versus signed. Function parameter has no effect outside the function. Well, yeah, that's reasonable. And then we finally get an error. So I would say CPP checker wasn't heavily used either. To be nice here. But why don't you have this if you're not using it? I know, I keep repeating questions. But it's something that we really should make up our mind, because it is important and it's there for a reason. It used to be there for a reason. And I'm not trying to be mean to the sudo team. They do a great job. They do good coding. They do lots of work, etc., etc. It does. That was not part of it, which would be reasonable to do, and a good thing to do. But don't ask me. I'm not part of the sudo team. Anyone of sudo here? Would be useful. No. I'm actually not saying sudo is bad. I'm not saying anything bad about the sudo team. It is a regular open source project like zillions of others. We played around with core utils. It's the same fun, etc. So there's a bunch of things where we find issues using the same thing. And it would be so great if in any open source project, or any project you do, if we could go through using -wall, -w extra, use Splint, use CPP checker, use Coverity, use PVS Studio, use whatever you like, but actually to use it. Provide the make targets, fix the warnings, get rid of them, because that's actually helping the code to be better, and that's mitigating potential security issues. So they, as I said, they're in good company in not doing it. Using static code analyzers is probably not very common. Who of you has ever used static code analyzers tools? Hands up. Okay, so you're a bit out of the statistics range, because it was probably a quarter or 1/5 of the room, but it's still not enough. Who of you develop software? That's more. Right? And that's the issue. That's the thing that we should really get into. It doesn't cost a cent. Splint is free. CPP checker is free. My CPU time is free. It takes time. But fixing the bloody bug takes a lot more time and a lot more trouble. So overall, you save time. And you do better code. You do cleaner code. It's paying off. It's paying back. And That doesn't cost you a penny. Yeah, straightforward, easy, simple. Yeah, sorry. You find some false positives. Splint has, for example, a specific syntax with which you could mark a section of code for Splint, do not check this, or that's okay, we've checked it. But that's an extra step you take. I mean, if you disable security features, you know this. I mean, if you look at a chainsaw, you have to use both hands to use it. If you use glue, some sticky tape to fix one of the things, you still can use it, but you worked your way around a security feature. And you know you're going to be in trouble when things go wrong. If not, you're lucky. So, yeah. There's some projects that actually seem to use them because they're not reporting any errors on these or any warnings. So we've got PGP and Nginx. They seem to be really friendly in these terms, which is a good example. And I said, make target, I love them. And as we already figured out, you shouldn't trust one tool. You should really use as many tools as you can to really find everything. Because as you pointed out, there's false positives, and at software projects, they won't find everything. And we've already figured they don't find everything. So use it. And for this simple example, we've got exactly one that identified it, which underlines what I'm saying. Yeah, that would be the first one you run if you had run it. And if you had read the warnings. I mean, I know plenty of people have recently seen one wearing a shirt which read, "It compiles, let's sell it." And I see this attitude in many projects. Hey, finally compiles. Bugger it. Ignore these bloody warnings. We've got some other recommendations. Use static code analyzers. Please do. All of you that develop software, even if it's just a quick and dirty fix, because nothing lasts longer than anything that's quick and dirty. You still find this in Windows. Quick and dirty operating system. And we didn't get rid of it. Use dynamic code analyzers if you've got a chance to. Use Valgrind, for example. That finds you memory leaks. That's really useful. Use gconf, which does branch coverage, so you know whether there's code that's never going to be run. You find projects where you actually have code that's so well hidden that's never going to be run. It's nice, but not useful. It looks better. And then run automated tests, which include things and security issues you found in previous versions. And we've got some examples of that. Anyone remember the ping of death? That's the elderly in the room, no kidding. Which, luckily, was found by Microsoft themselves. And like 10 years later, reappeared in Windows and needed to be fixed with IPv6. And I wonder whether they do any automatic testing or any quality management. Well, I'm just picking on Windows at this point. And we find other issues that reappeared after a while. And that should have been covered in automated tests, because you've once had the issue, and just check for it. I've recently had students implement Caesar's cipher in Python, which is obviously rather straightforward. And you've seen the usual bugs like modulo 27 or something like this, which is going to go wrong, right? So you ask them, have you tried like the last letters of the alphabet and what's going to happen? No, we haven't. We had this hello world sentence. Yeah, well, that doesn't break the code. So test any extreme values that should raise a flag. Think about what could go wrong. So I really suggest do automated tests and include whatever you've done wrong in the past. Do some peer code reviews. That's never bad. Because if you need to explain your code to someone else, it makes you write cleaner code. I've tried that myself. If I know the code it's not going to be read by anyone, it's dirty, and if I know it's going to be read by someone, it's probably being nicer. And that helps, and it also educates, because people will make mistakes. And if someone reads that and explains to you why it's wrong, you won't do it again. And if you've got fun, run some fussing against it, that's always bringing interesting results. oh, that's a bad idea. Or, have you ever tried to understand what you've done 2 months before? That's weird stuff, isn't it? Yeah, but it's a good point, yeah. If it hasn't compiled and installed yet, so. Why do we recommend this? And this is a bit more on a higher level. Because most issues that we find in modern software are due to bugs in the code. If anyone thinks of a buffer overflow issue, what did we miss out? Well, we didn't check whether the buffer is big enough that things will fit in there. If you pour a stein of beer into a schnapps glass, you realize it wouldn't fit because you measure. If not, you get wet trousers. Your problem. But in software, we miss this. We sometimes miss strn copy and just use strn copy. And that's an issue. But it's easy to fix. And it's an issue that creates buffer overflows. That allows us to take over other replications. Simple enough. We got the same for format strings. Yeah. Printf, user input, done. Well, that's going to go wrong. That allows you to overtake a program. And it could be easily found. That's all things that Splint will do. They'll find it for you. Straight. Off by one. We've already mentioned that in the Python thing. User after free. Yeah, well, that happens. Well, it's going to be found by Valgrind, for example, if not already by CPP checker or Splint. I like the SQL injections because it's a simple thing that someone who reviews your code will find. And we still find SQL injections being prevalent in web applications. So leaving the C code for a moment. And that works for lots of things. All of them are easy to be detected automatically. We do not need a human to read the code most of the time. So if we integrate automated tests in our program cycle, in our development cycle, we can fix them, we get rid of them, and we get more secure software. We don't run into the issue, oh, a software issue, we can't do anything about it. We don't have, well, CrowdStrike sitting around the corner, things like that. It's so easy to avoid. And as a result, this is what I believe we should do in IT security. We've heard many talks today about how we could improve security by using zero trusts rather than firewalling, etc., etc. But if we think about what we do in IT security, I like this picture here. It's probably not 100% roadworthy, this vehicle. Albeit, if you look at it, you'll notice here, what we see here, that is the actual security issue. Right? And I'll tell you who the bug fix is. That's the IT security tool. And this is what we do in IT security. We add this fabulous wife to our vehicle. We've added firewall, we have added anti-malware detection, we add whatever to fix that someone didn't use Splint, CPP checker, -w extra. And I think that's important to notice, because if we keep on doing what we currently do, we'll never get proper and secure software. We'll never get safe software. We never get to a state where IT security becomes the everyday thing, right? And we should reach that state. And if we continue the way we currently work, we'll never reach it. Well, I know most of you are not using any Microsoft crap, no Cisco's and CrowdStrikes, etc. So you're well off. But this unfortunate rest of the world, maybe we can help them. And what we do in IT security is mostly symptomatic here. We're not curing the cause. If you break your leg, take the leg, that's easier. You could use tons of morphine. Or you could just get it blasted and fixed and healed. Which one would you prefer? I'm just asking. I'm not, okay, I see some of you have favorite drug dealers here. And even the tools that we add to add security tend to be counterproductive. I mean, I completely understand what this person thought. Oh yes, my car is so weird, I can't really see where the corners are. That's going to help me to find the parking lot. I mean, it's a bit nasty to look at this like this, but if you think about any antivirus tool, what is your antivirus software doing? It's scanning each and every single file on your disk. If you're unlucky, it even sends them to the cloud of the respective provider for a more thorough check. Now, who's got confidential stuff on his hard disk? Everyone. You hopefully have your bank accounts, your credit card stuff, etc. on your hard disk, have you? Because you need to download them as a PDF, don't you? I think that's confidential enough. I'm not talking about anything else that you might have on your hard disk. And that's stuff that you're going to send to someone's cloud that you don't trust, or do you trust them? Well, German government has, or the German IT security office has actually claimed Kaspersky is insecure because they're Russian-owned. And they issued a warning, claiming a virus scanner needs to go through all the files on your disk. I was a bit afraid they didn't consider McAfee or Symantec or whatever, but fair enough, because they are unsecure, probably as well, based on that logic, except they're not owned by a Russian. But they're owned by a company who's might be run by a country or in a country with an orange-haired president, if things go terribly wrong today. So what we do want in IT security is basically that we need our customers, our users, to be educated to expect security. If any one of you buys a used car, you want the car to go through a roadworthiness check if you're not a car mechanic yourself, right? And it's probably easy to be sold if it's got that stamp on it. If you're manufacturing a new car, you need to have that car to be tested for roadworthiness. And that's why you trust sitting in a car. That's why we trust a car to go 200 Ks, right? And we're happy to do so. In IT security, it's different. Rather than providing real security, you get a nice white paper. And in the white paper, they write, it's secure, because we did some bogus password, blah, blah. I've read many of them. And I got so many of them, because sometimes I do some data protection stuff and you have to check IT security. And what people do is send you, this is a white paper. They even send you an email writing, but look, these people are all of these people are using our software. It must be secure. And we got a very weird baseline on IT security. Do you remember the presentation of Windows 98 in 99? When it blue screened with Bill Gates? I mean, I would blue screen with Bill Gates as well, but if you look at it, it crashed while presenting it. If you imagine, I'm from Bavaria, so I'll use the BMW. If you imagine BMW presented all new and he slams the door and the car falls apart, would you buy that crap? See, no, me neither. But we've got that weird attitude to IT. IT needs to crash. People at this time were happy that Bill Gates actually had a blue screen. And their argument was, we're not too stupid to use our computer, it happens to him as well. That's a weird baseline on IT security, on quality in IT. And this is what we encounter in real life. So we need to think about this. We have no security assessments. If you buy a bloody headset, that needs to have a CE sign on it. Even some kitchen aids, or whatever. Software doesn't. Just random white papers with some marketing guru wrote some weird nonsense on it. Any Land Rover owners in here? Oh, lucky me. They're notorious for their security, especially the older ones. And I do understand the dummies' concept of fleeing. We have, other than with cars, we've got all the crash tests. They're different around the world, but they're there at least. We've no measurable security standards for software. We cannot tell whether this product is safer than the other one, or more secure. We have no idea. All we do is we believe. Who of you thinks Linux is more secure than Windows? That's why we're here, isn't it? Who of you thinks OpenBSD is more secure than Windows? Who of you knows OpenBSD? Okay, that's approximately the same user group. So all of the others should have a look at OpenBSD. We don't even have a measurement for software quality. We cannot tell whether software is good or not. So this is a research area that I'm working on. But we need to be able to compare things. We need to be able to measure things so that we actually can do something. And my fantasy is that in the future, at some point, we've skipped the bloody Nutri-Score. Has any one of you ever looked at it? Oh, thank you. I don't either. But we need something like this for software. We need to be able to tell whether software is secure or not. And all we have is like reactive stuff. They're measuring how long it takes for a patch to be available. Hang on, what's wrong with you? If you think about being bitten by a snake, they wait, or they look how long it takes for you to get the antidote. They're not looking at the original quality. I mean, if a software has zillions of patches, they're quick, but they're there. That should be worse than a software that doesn't need any patches. But actually, in the measurements that we have nowadays, software that doesn't need patches is worse, because it takes longer to have a patch, obviously. So that's really odd. And I've got some nice examples which appeared rather recently, and you might have noticed them. SQL injection at American airports could make you airline stuff. And once you airline stuff, you can go through security checks easily. I love this concept. Unfortunately, they fixed it in the meantime. I should have updated my profile. But yeah, that's excellent, isn't it? Here is a screenshot of what I reported. And I really love this error message, which really gives you, okay, there is where I need to inject. It's not even blind injecting. This is helping to inject code. This is really supportive. And this is not the only website that I've seen. I mean, I haven't seen that one in real life, but I've seen zillions of websites giving exactly these error messages, which are really, really helpful in injecting SQL. I'll zoom in a bit. And they noticed there's something wrong. They run SQL map against it. Hang on, a few of you does web programming with SQL stuff in the background? Who of you has run SQL map against his own stuff? May I suggest? I know, this could have been automated, and this could have been fixed long before things go wrong. Some things are a bit harder to fix. This is a Kia. That is, I think, Korean for car. And the good thing is you could remote control them from your phone. I've never understood the concept of remote controlling stuff from my phone. A friend of mine's got an oven in the kitchen that could be remote controlled by the phone. Someone else got a coffee maker remote controllable by phone. Why? I mean, the only use case I see is remote controlling it from my phone and, well, making the kitchen swim in coffee. Maybe you switch on the oven. But, well, you could open the car. You could even remotely start the car. And all you need to know is a very, very secure password that no one could ever figure out. Your number plate. I mean, I do understand. This is a bit tricky to fix because that wouldn't be checked automatically. But it is an over top 10 issue what they found, because they could do this over an underprotected API. They could just register as a dealership. Once they're a dealership, which isn't checked against anything, you just could become a dealer. You could then have access to any car. I love it. I mean, rental cars were never easier to get. So, why are we discussing this here? Because we believe all of us could have an impact on these security issues. And all of us could change things by just adding these few little steps that we suggest as our recommendations in your own coding. And to maybe make people in the environment aware of these options. And by that, we could help making software more secure. If you've got time left, I mean, every one of us got time left. At some point, we could use this on our favorite open source tool. And maybe we find something. Maybe we could support the community by just sending in, look, we found this. Maybe you could add this to the makefile. I updated the makefile to do blah, blah, blah. It's easy. We all know this. We all probably contributed to some end, to some kind of an open source project at some time in our lives. So use it. Maybe if you've got an open source project, I would love to see these, and Aaron would love to see them as well, added to RPM build or the Debian build stuff. It's so simple. It's so straightforward. We mostly covered C in this talk, but obviously there is tons of other languages, and all of them are supported by the respective tools. So please do it for other stuff as well. And that's as much as we wanted to say. This guy here is Arjen, and he proudly wore for this photo his NLUUG conference T-shirt of 2003. So I should point this out at this point. Maybe some of you recognize it. I wouldn't, but that's him, so you've seen him as well. Thank you. If there's any comments, remarks, questions, notes.
We do have 4 minutes for questions and comments. Okay.
Yes, thank you for the presentation. I think it's a very fair point to make, very fair message. What I think is that, having worked as a developer also, there's a chase, a hunt for features all the time, because they sell, they produce money. And so I think we need to knock the developer people and technical people door, but also the manager people doors, because they take the decision of how we invest the time. And yeah, just most like a comment, but I think it costs nothing, okay, to add an argument, but costs time in the long term to fix it, maybe make more robust code, which would be, I think it feels great also for the programmer. But yeah, I don't know, how do you have any thoughts about this?
Yes, and that's part of the idea why I want to be IT security to be measurable. Because as soon as it becomes measurable, it becomes a sales perspective. And it becomes a requirement perspective. Because I could say it needs to have an IT security score of A. And unless that, I wouldn't buy it. Governments could make their decision based on IT security score when procuring software. So we got many situations where security score would actually help us. In the meantime, I would love if I'd see any government in the world that actually asks for secure software when requiring software, other than a white paper secure software, which isn't secure, but it's just secure on the paper. And I think that would then finally help changing people's mind. So we've got that mindset. Software is about to crash, we're going to be hacked. And if we change that mindset, people will pay for security. That would be great, but it's our job. That's our job to explain to people, look, we can easily do this. It just costs you an hour more on the project, but it helps a lot.
Just a small addendum to what you said. I think the U.S. government, like some U.S. government organization, was thinking about requiring their stuff to be written in either managed languages or some language that meets, like, where all these things are just not possible. So that'd be basically, yeah, that would help. Like a lot of the OWASP stuff is like not possible in many modern languages.
Yeah, that could help, but I don't think we too quickly move over from, say, C to Rust, because we've got many situations where we just got C code available. I like the concept the American government has come up with a few times in the past. I mean, at one point in the past, they came up and said, we want a documented, standardized file format for Office documents, which should have left LibreOffice or OpenOffice at this time as the only possible solution, because they got an ISO standard. Magically, Microsoft came up with an ANSI standard 6 months later. Now the Department of Homeland Security has said Windows is deemed unsafe. But does it change anything? And I think, again, we got a bit of an issue in how governments are lobbied.
30 seconds question. Someone in the front rows, maybe?
If there's no 30-second question, I'd say thank you. Maybe you do some better stuff now. Thank you.
Thank you.
Thank you.